Okay, everybody, that was great. Let's move on to our next session here, our literature review session with Dr. Anvita Marishi, one of my former graduate students that I'm actually learning from today. She's phenomenal. She's got more masters than Tiger Woods, I think, and a professor in the professor series. That was a joke, okay?
But a better marriage, right?
I'm not, yeah. I know I'm not funny. That's why I'm a dentist, okay? But anyway,
that's right.
Yeah, we've got our ravers and our ranters in the background there. All right, so let's get going here. Let me bring this presentation up here. Okay, you've got the ball, Anvita.
Okay. Hello, everyone. Welcome to episode 3 of Dental Raves and Rants. And I would be doing the literature review section again with you guys. And today's topic is going to be additive manufacturing of dental ceramics. So we all know for several years, subtractive computer-aided manufacturing, CAM, commonly used for dental ceramic prosthesis fabrication, has been working. But some limitations such as small areas that are difficult to machine, and there's a lot of material wastage when we mill some ceramics such as zirconia. So now people have been looking at alternative strategies to manufacture these materials, and because additive manufacturing just picking up overall in the dental field, AM of dental ceramics looks like to be the so-called future of restorative dentistry. We don't know yet. So just getting into the definition, ASTM defines additive manufacturing as a process of joining materials to make objects from three-dimensional model data, usually layer upon layer, as opposed to subtractive manufacturing methodologies, which uses a CNC machine to do the same. I picked this paper from 2020. We are 4 years after this publication, but just to review what is or was out there, we have made progress ever since this paper was published. Marta and Amir Ali talk about the applications of additive manufacturing technology for processing zirconia. So this paper discusses some current AM technologies to manufacture zirconia, such as SLA, DLP, which is direct light processing. Material jetting is another one, inkjet printing, as we call it, and then material extrusion or fuse deposition modeling, powder bed fusion. One of the more common methodology under this category is the selective laser sintering. Then there's also direct energy deposition or laser cladding, sheet lamination or laminated object modeling, and then binder jetting is also one of the processes that can be used to manufacture zirconia via 3D printing. So what is the current evidence? There have been several groups that are looking at where we stand in terms of the mechanical properties, so to speak, and also how is this stuff looking under the microscope. So Ebert et al. Reported, as per this review that Marta did, strength to be around 763 megapascals. And then the problem is the CM analysis reveals a lot of surface defects, internal defects, and high porosity in these materials. So yes, with these several technologies I mentioned in the previous slide, it is possible to make a 3D printed zirconia material, but at the same time, we have some limitations that we need more technology and advances to tweak upon. Some of the manufacturers that fabricate 3D printed zirconia are 3D Ceram, Admatac, and Lithos. And then the properties of these materials have been listed by some of the manufacturers, where we're looking at the particle size to be between 0.1 to 0.8, and then flexural strength to be as high as 1,000 for some of the materials, and some of the materials are reporting 700. Again, this is manufacturers' reported data. We need more people to commercially produce these materials because some of them are very limited to R&D only from these companies. So there's still not a commercially available product that is ready to be used inside the mouth. And we'll talk about one of the products that is actually available and how it differs in the properties to currently existing materials. So talking about some of the current problems we have with 3D printing of zirconia is sintering distortion. Porosity control is a major factor. Poor geometrical accuracy, but some of the studies do show good trueness and precision. Some of them don't. But overall, it's a generic problem. Poor optical properties, because with machined zirconia, we are already looking at some phenomenal gradient materials. So doing a layer by layer deposition of 3D printed zirconia is going to be the next challenge. Marginal gap, we all know clinically acceptable is between 50 to 120 microns. And some of the papers do report that we do get that kind of marginal tolerance with 3D printed zirconia materials, whereas other studies report some data otherwise. But we are there. This is a technique that was described by, again, Amirali and Marta to produce gradient structure by layer, multi-layer jetting of these materials. So going to our rant section and just building up thought-provoking ideas for today's discussion, that does additive manufacturing of zirconia have a real advantage over CAD/CAM? Or again, as our podcast members say, are we creating another problem to solve something which really is not a question that exists? Meaning, we have an ideal material, and are we looking for more stuff to do by creating a 3D printed zirconia for us? So it's people promoting this also talk about reducing the wastage that a milling would generate, and also, are we gaining anything in terms of the production time? Is additive manufacturing reducing the production time of zirconia restorations that we're already generating by machining them? So the current materials that exist are actually under the umbrella of the hybrid nanoceramic, and they're not actually 3D printed ceramic crowns. And I'm hiding the manufacturer name here, but it's just want to talk about what is out there. The flexure strength of these materials are with around 150 megapascals, and the modulus around 7.5. Again, composition-wise, they are a hybrid nanoceramic, and we can talk about that more in our discussion today. And this is, again, my slide about Raves. What's good about the technology? So yes, this looks like an alternative technology in future for ceramic restorations. Future looks promising with more advancement of technology and research that is needed. And this is another review in the Journal of Aesthetic and Restorative Dentistry that is very interesting to look at in terms of processing parameters for the fabrication of all ceramic crowns. So we talked about a lot of papers and evidences out there, and I will lead you guys up to questions. So
okay. So I guess my questions to you from and also from what I've seen here. So what I think I heard you say is that we're not really there yet with 3D printed ceramics. What we think of as zirconia or glass ceramics, but there's been a lot of movement in that area, and we're going to get there someday. Was that accurate? Did I assess that correctly?
I'm only talking about 3D printing of zirconia.
Yes, well, zirconia, or I've heard that we are also in the beginning phases of 3D printing glass ceramics like lithium disilicate.
I don't have a paper regarding that currently.
Okay.
In this.
But your knowledge base, what I'm hearing you say is we're not quite there yet. And what I've seen with zirconia so far with the printing of it, I'm loving the concept, but the physical properties seem to be significantly less than the machinable materials, which I'm not that concerned about because zirconia is such a strong material. What I'm more concerned about is I haven't seen optical properties, and I believe you touched on that come anywhere close to the machinable materials we have today. So is that pretty much what you see in the papers and what you've seen in your experience?
Yes.
Okay, great. Now you briefly touched on 3D printing of what people are calling nanoceramic materials, okay? And that are being sometimes sold and called a ceramic crown. I'm assuming you're talking about these newer versions of 3D sort of resins that we've talking about, like several on the market. I could name 3 or 4. Sprint Ray has some material. Rodin has some material.
Correct. I don't want to name them. Yes.
Well, yeah, I'm not trying to signal any particular one out. I would like to go down that path a little bit with the team. We've got several. We've got Dr. Ortiz, obviously Richard, Dr. Young on the line here, and you. So we've got.
I would like to go down that rabbit hole that pisses me off.
Yeah, well, there you go. That summed it up too. I think I'd be a little bit more politically correct than you, but that's why we have.
Well, you're the one who named them. I didn't name anything.
Yeah. So
I still want to get sponsored by these companies, but
yeah, but
yes.
Yeah, well, go ahead, Dr. Young. Go ahead, take
No,
over.
I mean, I want Miguel to comment further on why he's so pissed off.
I think we allowed the companies about 10 years ago to make blocks and misname them. And then now it has gone out of control. This idea of nanohybrids, nanoceramic, ceramics here, ceramic there, when we know that most of the blocks that you don't need to put in the oven or that you can't put in the oven, let's say, they're resin blocks. The matrix is made out of resin, and we have a filler content of some kind of ceramic sometimes, most of the times. And the companies are trying to put the word ceramic in there because it's more appealing than the word resin in it
to sell.
But now it's moving to the 3D printing, in which we're all talking about 3D printing ceramics. And as Ed said it, I don't know if there is in the market right now, in the dental market, something that dentists are using, that is actually a 3D printed ceramic, meaning are you at the end having a glass matrix? Did you heat it up somewhere to melt all this glass together in a way, or we're still talking about resins and fillers? Because I think it's getting out of control, the misnomenclature of this, and it's misleading.
Right, it's extremely misleading. And so we should define a couple of things. I mean, if you look in the ceramic literature, the official ceramic societies, the literal definition of a ceramic means a material that's made of under the densification, semi-metallic material made by the densification of heat, and by definition doesn't have carbon in it, okay, resin. Okay, that's what a ceramic is, okay? And zirconia would apply to that, believe it or not. Glass would, so would porcelain under that definition, so would lithium disilicate, okay? That's made by the densification of heat from a semi-metallic compound, okay? Now, resin composite that we've had around since the beginning of time, okay, we say resin, but it really is a resin composite. By definition, those are materials that have a resin matrix. They've gotten better and better over time. Those of us that practice know there are some excellent materials over there. And they've had some sort of ceramic filler in there, quartz, a few other types of microscopic pieces of glass, zirconia in some cases that are bound by the resin. And the two limiting factors for that type of material, one has been the size of the particle, okay? Not so much the type of particle, whether it was quartz or zirconia. So the size of the particle and the number of particles in the resin matrix. And then number three, how well the manufacturers were able to attach those microscopic ceramic particles to the resin matrix. And there's several chemical technologies they do that. So the better they do that, the number of more particles, the size of the particles, and the bonding of the particles between the resin and the matrix, the better resin composite we have. We could name Filtech Supreme Ultra, we could name something from Kerr, we could name something from Ultradent. There's several good products out there on the market that are very comparable that we've done very well. And to Dr. Ortiz's point, to Miguel's point, is what's happened is we now have 3D printable materials that actually have worse physical properties so far. They're not as well filled, they don't have as much filler particle, and in fact, when you see them report their physical properties, like Dr. Maharishi just said, the modulus of elasticity is actually less than a regular composite and significantly less than dentin, which creates its own issues. We can get into the mechanics of that or the chemistry of that, but also too, because of the lower filler, we don't know yet how well they're going to wear in the mouth. We do have some interesting anecdotal reports from people or some initial research coming out that they don't wear as well as our regular chairside, light-cured composite. Now, is the technology exciting? Absolutely. But I could not agree with my rant pro more, Dr. Ortiz, that we have completely mislabeled these. These are not ceramics. Okay, they're not a ceramic crown. I guess if we look up the word hybrid, we could kind of define them as a hybrid, possibly, because they have some ceramic particles in there. But we could then define a resin composite as a hybrid too. So
exactly. It says the only hybrid in the market right now, if we want to even make a hybrid category, is anamic.
Yeah, anamic. I couldn't agree more. I would say that those of you that don't understand, anamic is a very unique material. In fact, it's the only really unique material out there. Okay. The company was able to develop, with some help from some very famous Dr. Giordano, a few others out there, Bob Kelly, a material that has a matrix, a mesh-like matrix. Get a visualization of a Brillo pad. Essentially, you all know what a Brillo pad is, of a feldspathic glass. And actually, because the fibers are so small, it has a little bit of flexibility to it, which normally a glass wouldn't, and then it's infiltrated with a resin. So realistically, by definition, that's probably the only material we could call a sort of...
and the beauty of a dynamic, not to rant always about dynamics, but just to close on dynamic actually, if you want to, is that it did get the modulus of elasticity to be right in between dentin and enamel, because you get the glass ceramics that are more like enamel but don't like to be sitting on dentin, and then you got the resins that love to be sitting on dentin but they don't love to be sitting on enamel as much. And the genius of Giordani was to say, hey, we can mix these two things. The modulus of elasticity might be right in the middle, and it was right in the middle. So when it comes to this misnaming of products, especially coming from the blocks, that all the companies who were making composites, when the blocks came about, it was pretty easy for them to make a block and then make it into a composite block that they started naming nanoceramic, ceramic this, and now carrying into 3D printing. The problem with this misnomenclature, not to be a Nazi of the nomenclature, is that for the average dentist, this is a confusing topic to begin with.
Right.
Dental materials is confusing to begin with. So if on top of it we misname it, when they're in a trade show, when they're in a congress, when they're in front of a booth, they're already confused about what they're looking at, and then they're told that it is something that is not. It is making it really hard for us educators to clean that mess up. I'm sure you see it all the time.
All the time.
With your students who are our colleagues who are making clinical decisions. So it also shows how the industry has truly no control.
Right.
Where it's a free-for-all right now, in which you will think that the ACP, the American College of Orthodontists, or the Glossary of Pros, or the ADA, or someone will be a little bit more watchful and have a say on it. But it shows the weakness of our profession, and the industry sometimes takes advantage of that weakness, that nobody's watching.
Yeah, and to expand on what you just said too, somehow somebody got these materials through the ADA and somehow got an approval for the term ceramic crown, which is completely inaccurate by all terminology that we've already touched on.
So
now, I guess the good thing right here would bring to a summary. Here's what we can say we know, about these materials.
But I had a question.
They're a resin composite. Okay, all right. But we do want to summarize so we can answer Dr. Ortiz's question.
As you wrap this up and summarize it, I want you to wrap it up and address it on a statement that Pascal Magna made at the second colored appearance meeting, the second one we had after the Texas. All day they lectured about zirconia, and then he got up, and if you remember, he and Michelle closed it down, and he said, I hate to blow you all out of the water, but that material will not be the end all. The ultimate material is going to be a resin-based possible ceramic additive material, and that will be the ultimate. How close are we to that statement? Because and it was kind of shocking because everybody was talking zirconia, zirconia, zirconia. How close are we to that statement?
Okay, so you painted a very broad brush, okay? And let's I guess deal with your question. So we all know Pascal very well, and I've talked to him many times because we used to come over and teach for me at UCLA. As many of you know, he was at USC. All right, his belief, and a lot of people's belief, is that we are going to have some sort of hybrid material that we could define as a hybrid material that has some of the best properties of a ceramic. Okay, very low wear resistance, very high wear resistance, very low wearability against the opposing dentition, very high resistance to fracture, okay, but also has some flexibility, okay, and some ability to bond to a tooth, like the DEJ, right? So those two things, those descriptions of physical properties, some of them define a composite today, a resin, and some of them define a ceramic. And then I know that he has been working with industry to try and develop that hybrid material that has the properties that we said, the best properties of both. How close we are to that, I don't know.
Dynamic,
but I do
dynamic
think I do
process.
think that
I think we're close.
we're close.
I think we're close. I think we're close because resin is not a bad word anymore. And
No,
it
it's
used
not.
to be.
Right.
And resin is being used and sustained by the literature in posterior minimally invasive restorations, as spinal restorations, and it's working. As you and I and all of us here know why it works. So as resin cleans up its name, and we start seeing more studies and more people talking to each other, yeah, I use Smart, it works. Yeah, I use Lava, it works. Yeah, I use Grandio, it works. As those things continue to happen, the fact that you don't need an oven is a
Huge.
very appealing thing.
Correct.
And as resin cleans up its name, also what I think is going to happen is my message and many others' instruction message, which is, I don't care how much the restoration lasts, I care how much the tooth lasts. That is also resonating with a lot of people. So this idea of us not trying to find the everlasting material is also permeating through the industry right now. And I'm starting to see people be more comfortable, like myself. Yeah, I can put a resin restoration, this indirect in the posterior, and I know it's going to work.
Yeah.
And the advantages of being able to repair it, the easier to grind it off, whatever you want to do it, like the easier of finishing and deliver it, it's going to take color that, staining and glazing and baking and sintering.
Right.
So I can see what Pascal is doing, and just the shift in mind that now resin in the posterior is not a evil thing. That's huge.
Is it
And-
the closest thing we have?
Agreeing with you, but a caveat. Now let me come in here, please, okay? Because that we could argue based on some of the early points you and I both made that saying the word resin only, okay, also is a misnomer, okay?
Correct.
Because the materials that are doing the best are resin composites. It's
That's what I meant. Resin composite.
but say what you mean, okay?
Yeah, that's what I meant. Resin composite, as we call it, not just pure PMMA. I was like resin composites, right?
Yeah,
Like
okay.
Nanofield resin composites. Those are the new ones, right?
Right, and then how the technology is involved and what's made it better is those 3 points: making the particles smaller, getting more particles in the mix, improving the resin component of it a little bit, a little different, a little less shrinkage, and better bond of the resin matrix to
Bonding to the tooth,
and bonding to the tooth,
and understanding how to prep it. I think those things are huge.
And I couldn't agree more with you. Your statement, we've all talked about that, and for years, all of us here, that the continuum. I couldn't agree more with. I'm more interested in what's best for the tooth, not what's for the restoration.
What do you think, Rich? How far are we from it?
Well, that's what I was asking. Do you think dynamic is close? I mean, because the reason I asked is because in that era, in fact, that meeting, I was a huge sculpture fiber core guy. I'd used it for years, and I have 24-year restorations. They don't look anatomically perfect, but sound as can be. And I had showed those to Pascal, and he goes, "That's it." So I'm just curious where. I've been waiting for that day where we have I suppose it would be a ceramic infused, resin-based, composite-based material. And with I think it's a jet printing that's the next level of
Yes.
technology in
Yes.
printing. Well, with one of my conversations with the industry leader this weekend was about when jet printing really becomes viable. This is when a lot of this is going to change. And you're going to see these materials both with color infusion and all that. Now, I don't understand jet printing, so I can't comment on that.
Anvita, can you explain it, please?
Yes. So basically, I'm going to read from the paper that I have open here. So direct inkjet printing basically relies upon layer-wise deposition of suspensions via printing nozzles onto a built platform, and it is similar to robocasting, except for the fact that the ink is in the form of droplets rather than extruded filaments. So among the technologies that are available for additive manufacturing of ceramics, direct inkjet printing is the only method capable of producing fully dense green parts And then in order to fabricate green parts via DIP, the processing parameters need to be optimized. So that's what we are looking at. And the last paper that I discussed actually discusses these parameters for improving upon direct inkjet printing. And this multi-layer printing, direct inkjet printing, also allows for layer-by-layer deposition that can give us the gradient that we would like in a restoration.
Right. And let me make a simplification statement for the audience. Most of you have all seen printers today. Your standard printer that is printing with a very low viscosity resin. Direct inkjet printing, think of it this way, to be able to layer a much more viscous material, okay, almost like a paste, like a composite paste or a ceramic paste, okay, that is much higher fill. So the problem that we have with the printable materials today, the filler content is so low, they need it to be low, so they have a low viscosity material. That's why we're concerned about the physical properties of the material. It comes back to the filler content, the amount of ceramic in there. And
it's a flowable. It ends up being a flowable resin.
Yeah, maybe a good flowable, but it's still a flowable.
Yeah. The percentage of zirconia ceramic they use is 27%. Ceramic suspension contains 27% of zirconia.
Right. Yes, but that's still not that different than a puck, okay, where there's a lot of air where you fire it where it shrinks, okay?
Right.
Direct inkjet printing that they're working on with resins, okay, resin composites. Better way to say it, resin.
You know what the interesting thing is? The problem that the industry is trying to solve with using 3D printers to get your final restorations with the same materials that we already have. The problem that we're trying to solve has nothing to do with dentistry or the patient. We're trying to solve the problem that there are some companies that have, I don't know, higher share market percentage of milling units, and they keep selling it at such a high price.
Right. I agree.
When they already made their money, that now is pushing the whole industry away from milling units. And we're going to spend all this time, as we say, with zirconia and effort to refine this, just because the one who are selling you the milling units, which work, is still charging you exuberant amount of money when they should start dropping in price.
Yeah, that's the problem. But there's still some other benefits too, okay? The benefit of printing or waxing and pressing or something like, is one, the layering, but number two, you can work with different geometric shapes. Machines basically today, especially the ones in dentistry, maybe not $1 million machines in industry, are more limited in your preparation design. And so just like if you did a gold crown, you could wax to almost impress, wax to and cast to almost any preparation design, okay?
Correct.
A lab could solve that problem. The machines can't do that. Okay?
I agree with that, but the fact that you can print or create a restoration of any shape, let's say to the extreme, any shape, when milling you cannot mill any shape, doesn't really solve a problem, because the restoration still has to sit on a tooth and it has to draw. So even though if you can mill a crazy thing, if you cannot deliver into the tooth, that crazy shaped thing has no meaning. So in reality, the limitation of the millings actually go hand in hand with the limitation of your drawing path or your preparation. So it's not really a problem. It's an advantage and a benefit that I wonder if we even need.
I'm going to push back on that because, and I know you're a lab tech too, so I'm sorry if this, and I do some work for some other people, I don't know if you do it either, but if, somebody doesn't, the internal aspect of a preparation, the incisal edge of the preparation, things like that, the mill tends to compensate by creating a lot of extra space between the.
I agree with it.
If I'm pressing and or printing, I can fill in that space.
Yes.
You're right, unless it's undercut. Okay, that's a different issue. So I do think there's some other advantages, and then the multi-layering to that, and potentially I think
I'm excited about the multi-layer. Can you imagine if we can multi-layer finally by AI or whatever parameter that we have pre-made, really everything from the inside out, like ceramics dreamed and ceramics built it. That is an exciting thing. But at the end of the day, I don't know. Are we wasting our time? Are we letting the industry guide our dentistry? So I have a feeling that in the last 2-3 decades, where the industry is telling us where to go and not us telling the industry where we need to go to solve the dental problems of the patients.
Right.
Does that make any sense?
Right.
It's starting to be like the pharmaceutical companies that they are making forever pills that you need to take based on what they need, they can make money on, versus making the drugs that people need.
Yeah, but I do think 3D printing does solve a problem. Okay, I really do, and I think it's going to open us up to other materials. And there's an interesting problem with machining, especially glasses. Okay, even more so than zirconia. Man, the burr cost, the burr use. We just machined 20 times. We just machined 200 restorations in the last few days for the course coming up. And basically, I prep well. I know you prep well. Everybody on this page preps well. And there was still some little issues with occasional chips here and there, that we had to remachine, or the sprue popping off or breaking, things like that.
Yeah, but you have 3D printers in your office. They're not reliable. Like they work whenever they want to work. They don't always print right. We will have issues too. Like it's a very moody system, the 3D printers.
I mean, the current technology, but the newer tech.
I mean, you had issues with casting gold as well. I mean, so to me,
right?
The printing idea,
especially when you miss the crucible,
it's quite solo. When you just so the technology,
I think the printer technology as proposed, okay, the direct injection printing, okay, but definitely is going to be a significant improvement over to what we have.
Well, and you will
obviously I'm not agreeing with everybody at the table here. Yeah. I would love to have that perfect hybrid material that I could print, okay? And yes, there are issues with printing. How do you sprue it, right? You're going to still have a sprue. You still have to finish it a little bit, things like that. And there's going to be
jet printing change that. Does jet printing change?
No. You just Well, supposedly they're theoretically through a hologram you could 3D print something, and it just sits on a tabletop and yeah.
I like what Pascal said. I think I can see what he's saying. I see a more feasible that dentists rely on composite resins in the near future more and more, rather than us completely figure out how to truly 3D print a ceramic material. I think we're going to get much more comfortable with using composite, direct 3D printer, mill, whatever, and that composite resin will take over more. I think I can see that. And that will serve the idea of how do we 3D print ceramics.
No, I think you shifted off here. There's everything. He was relating it also to
but from a material and a manufacturing perspective, it's going to be printing, and it's going to be some hybrid composite resin that's going to be some future material. Okay, I agree with you on that, Miguel. And also too, you'll have some side shoots. You'll have some lithium bisilicates printed in zirconia. But I could see, other than bridges, obviously for zirconia we're going to need a bridge or maybe some cool material we don't know about. I think we'll see way more resin composites in the future.
All I'm saying is at some point, I think as Pascal too, was the jaw flexure and everything with the implants, the all-in-4s, to solve the strength issues, you'll easily embed in a jet printing system. You could easily embed a sub frame and inject around that. His whole point was back to what Miguel has said before, and it was really funny at that meeting because everybody was so hot on zirconia. Literally every speaker for those 2 days, and the last speakers, and he just gets up and says this stuff is going to be gone in 12 to 15 years. So
yeah, and also now you said the second meeting. Wait, okay. So I'm going to push back on this, dude. Okay, a little bit. Okay, you said the second. Yeah, isn't that 10 years ago? That's 10 years ago, that meeting.
Exactly.
It's 10 years ago.
No.
It's 10 years later. We're 10 years later. You just said 10, 12 years later.
We're at 14 years now.
It's 14 years ago.
Probably, yeah.
Okay. He said, so you just said that he said 10 to 12 years from now it'd be gone. It's bigger than ever. It's bigger than ever. It's bigger.
He was off on the numbers, but I think it's
about 2 weeks ago.
It's been gone from Miguel.
Yeah, about 2 weeks ago, I did a case.
Okay, so you're making a point that isn't true. Okay, Okay, and you're giving somebody's opinion, a very valid opinion. No, I'm not gonna. I'm just trying. I'm just trying to let you know
the reality and intent.
That's when you become the moderator.
Just like you could say 10 to 20 years.
I'm really that. We get you with the moderators.
It's 14. Okay.
I think moderator is creating.
You don't know where it is.
You know about 2 weeks ago.
All right, here, so I get a word in edgewise.
Yeah, well, okay, Mike, but I wait. By the way, I wait.
Point is, if you're speaking for saying 10 to 15, you don't know what it's going to really be. It might be 20. You hope it'd be 10 to 15.
I think that if you lower, you can do a very low voice, right? Let me see. Let me hear.
That's
Richard.
awesome. I like that.
I can do it.
Yeah, I like your
Low
ball.
voice.
Yes, he can do a low voice.
Listen,
You could have been a 1-800 number in the 90s, make a lot of money.
listen to the
Sure. I let you finish, and then I push back, and then you jumped in, which is okay. That's the nature of we're random.
Let me share something related to what we're talking about. About a month ago, I did 3 cases. But remember that day I tell you, like, this week I'm doing a lot of cases. I put them on together.
Yeah.
So I did a couple of full arch cases that needed, extraction implants and an immediate loaded, like the classic column 4, but more complex. Patient had implants, whatever. So we, extractions, couple implants, photogrammetry on the moment, and then design ExoCAD and 3D print the prototype, the temporary restoration. So as I was about to 3D print it there, I printed 3. Why would I print 1 arch? Might as well. You put it on the... And then, now the patient has one in the mouth that is temporary, right? Until heal. I'm not going to take a final impression again, except for the tissue as it heals. But I was thinking at the moment, I'm like, and why do I have to switch this to zirconia? Right?
Yeah.
Why? Like, it's thick. This thing is not going to break. And if it breaks, I have 2 more in the drawer.
Yep.
Okay.
Like, I that thought process, I always think that if I think of something, I'm not a genius. Like, a lot of people are going to start thinking of this. And why do I have to switch to zirconia for 6-7K, whatever the lab is charging you? Why? And when it breaks, I did another 6-7K of zirconia. I already have the design. Go with this plastic home. If you ever have an issue, come back. I have 2 more.
Right.
And in that sense, I wonder if, again, now resin composites in the area of full arch reconstruction, mandibular flexure and all that, I can see a future there. The industry, did a little bit of experimenting with PEEK, right? Like, it's going to save the world. It didn't. But we were already trying to get away from zirconia, especially in Europe about 5-10 years ago. So that's an interesting question too. Do we need all the Olom 4s to be zirconia? If you know how to print and you have a printer that now and you're doing 1-day crowns, are you going to give a lab $5K for an all zirconia when you can just print an arch? And probably pink resin on it is here.
Now, like Miguel,
Were you asking me a question?
well, no, I was just saying, Miguel, I have a case in right now, and that exact same thing's been going through my head. Because the actual the prototype looks great, it's holding up great, and we printed another one. I mean, why? So, I agree with you on that. Why do we have?
Well, okay, so let me answer the question. Yeah, you guys, I'm neutral on this. Let's revert back to a second. My point would be, as long as we have a material that satisfies our requirements, I'm loving the idea of a composite resin, but the maybe future properties that we have, that we can layer color with a 3D printer. We have the physical properties that will resist fracture. We have the physical properties that'll wear like enamel. I'm all on board for that, okay? What we don't have is that material yet. So we are stuck a little bit in the zirconia space right now for bridges. And we had this discussion last time, zirconia or Emax. Or lithium disilicate or Suprinity or any of those light materials. I'm 1,000,000% on board with that, my friend, okay? Until we have that material.
And Rita, what do you think? Is Pascal right?
That's it. I was not at the meeting. I mean, but I think hypothetically speaking, if we have something that that has best of the both worlds, then we have our answer for the perfect material, because we have been chasing this perfect material for so long. That's my take on it.
Okay. All right.
Thank you for that review, Rita.
Yeah. I know I got to run to some academic function. Okay. So.
Yeah, it's a group leader thing. So.
No problem, boss.
Yep. And then when you decide the topic for the next one, let me know. And,
Okay.
Yep.
All right.
All right. Thank you. I like Mike Dr. Young. You can
Yeah, we
moderate
love that.
more.
We love that ball, man. Big balls.
I think he should open every chapter.
I think so. And then I know
gentle race.
this is
I just really think so.
this is Richard from
All right, now,
Amazing.
we are now going in
my big ball.
north south.
And we,
Yeah.
by the way, we should start this segment with Ace from AC/DC, big balls.
All right. Thank you, guys.
All right.
Thank you. Bye, everyone.